this first episode of the Godot multiplayer tutorial series, I'm going to cover the general overview of the series as well as the basic things you should know before you start building a multiplayer game. I would as well note that you should probably have made a couple of other games in Godot before attempting to follow along with this series. I'm not going to cover basic Godot stuff like scenes, scripts, adding scripts to nodes, etc., but I'll try and make it as easy to follow along with as possible. This tutorial is for a shooter game, as in 2 to 20 person lobbies. Fast-paced gameplay is taken into account, so if you need rollback for very snappy shooting, hitting headshots, that will be covered, so clients will see their input happen instantly and they won't feel as much lag as you might with no systems to take that into account. And I will generally be following AAA style implementations in Godot Engine. This series will cover building a very simple 3D scene. That is mostly up to you to figure out how you want to structure your game, what type of game it is. If you want to build a racing game or something, this will still be applicable to that. But I recommend that you follow this exact tutorial just for the sake of this to learn it, and then you can apply the same concepts to your own game. I will cover the fundamental things to understand about the way Godot handles multiplayer. So how RPC functions work, how RPC parity works, etc. All of these things that Godot does not explain perfectly in the documentation, or that it makes sense to cover again in the series. This series also covers creating a client-server setup with 2 different projects, which means that I have a client project over here and a server project over here, which will end up having similar structure, but it will function differently. So the client will request a ping over here, the server will receive the ping over here. So this keeps it much more organized than having it all in one project, and it is more industry standard because Godot Engine provides the capability to build your entire game on one project, but it generally gets very chaotic and very hard to reason with and expand later on. That means that I will cover writing clean and expandable netcode, so how to organize your functions sensibly, how to make sure that they can be expanded and you can add new behavior to your project without reinventing your entire system, and it should generally be able to carry you all the way to having a complete game. The series will not cover building an entire game from start to finish. There are many other tutorials that will cover stuff like that, how to use Godot, how to use the scene tree, how to use animations, etc. I will cover the networking side on a very basic project, and that will be as far as this particular series will take you. I'll also not cover Godot basics, as mentioned. Higher level network architecture like matchmaking, server chunking, creating user accounts, security, etc. Those are all out of the scope of here because I think most people want to just be able to play a game with their friends, which is what this is for. If you do need more information about those higher level concepts, or you're building like an MMO or a larger map which needs stuff like this, you can check out the link in the description to the best other Godot multiplayer tutorial series that I have seen on YouTube. Alright, let's get into it. So the most important thing to know about is RPC functions. RPC functions are regular functions with the @RPC annotation, which is in orange, just like @onReady or @export, which are also annotations, and they're both orange. So RPC is an annotation which belongs on functions, which means that it comes directly before it. That's all it means. So I could put it like this, I could put it like this, and it would have the default values, which are authority, call remote, and unreliable, which I'll explain in a moment. And an RPC function is a remote procedure call function. So remote as in on another computer, procedure as in function, and call as in it calls the function. This nothing function doesn't do anything. That is probably because our implementation goes on the server. The way that RPC functions work is that you'll have one on the client and one on the server that match exactly. So if I go into the network core script, which is ping related stuff, and I check out the RPC functions in both, which I've separated by region, I'll explain that in a moment. We have on the server sping, which stands for server ping. So every function that has behavior on the server, I put an S underscore, and every function that has a behavior on the client, I put a C underscore. So you can see that these functions both have RPCs, and they are both, this one has the RPC behavior on the client, this one has the RPC behavior on the server. But as you can see in the opposing region, so we have RPC region here and RPC region here, and then over here we have RPC parity below and RPC parity. This function, sping, is on the client in the exact same script and it has the exact same arguments and RPC annotation as on the server. Any peer reliable and any peer reliable, which means that this setup will pass the initial check. If your functions on both scripts do not match exactly, for example, if we just had this, and remember that the default from this script is unreliable, so that's the default if we don't provide it. If we just have this, it will assume we mean unreliable, which means that over here, if we took this out, the script would realize this function is any peer unreliable, and it's called sping with these arguments. But this peer has any peer reliable, which means that even though it has the same function signature and return type, it will not pass, and it will error out and say this function will not work, which means that none of the RPC functions on this script will work. So once you've made sure that you have the exact same RPC functions on the client and the server mirrored, so the client variation does not have any functionality for server functions, and the server variation does not have any functionality for client functions, as you can see with the pass, then you have set up your RPCs correctly. So the specific RPC annotations are relatively important, but there's mostly only 3. There's a 4th one called transfer channel, but that's not as important for this because we can always assume that we set it on 0, and if you need to know more about that, you can read the docs, but it will have little effect on this particular tutorial. If we give the function the default behavior, authority, call remote, and reliable, that means that it can only be called from the network authority, which can be changed, but we'll always have it to be the server in this tutorial. It will only call on the remote computer, so it will not call the function on this side. As you can see, we have all of our functions that are for the other side are pass anyways, so they don't do anything. And then over here we have the behavior, which means that we don't need to call this one, we only need to call this one. So when the client calls s_ping.rpcid, we only bother calling this one over here, not this one. And unreliable means that the client, or whoever's sending the packet, will say call the function, and it will not wait for a check to resend it. So if we mark one of the functions with reliable, then as soon as the server or whoever receives the call, it will respond and say I have received it, and then the client will not send the information again. But if the client does not receive that confirmation, then it will immediately call it again and make sure that the call gets there. So for critical game events like the round changing or somebody dying, we need to mark every RPC that does something very important with reliable. But if it is something that is called every single frame, like the position updates or input updates, then we don't need to call reliable, because by the time the server has confirmed we've received it, or the client has determined that we haven't received it and sends it again, we'll probably have sent more recent data anyways. So only a few functions on the entire project will have unreliable, because only a few functions will be called very frequently, position updates or input updates or pings or something like that. Other than that, every single function will have reliable, because game events are important to synchronize no matter what. Now the next important things to note are organizational tips that I have sort of invented or come across over my time building a multiplayer game myself. If we just name every single function with the name of it, it's not exactly clear what the functions are doing. Because for example, if we have ping and pong, in this case it's relatively obvious because I guess I'll fix this. Because we are pinging from this side and we're ponging from that side. So of course the client is pinging and the server is ponging. But in events where we have, for example, the client calling the server to say, I just built, we might call it player built, and then we'll have a player built function on the server. But then if we have the server calling back to the client, we want to tell every client, hey, a player built. So what are we going to call that? Probably player built. It makes sense to call them the same thing because they're the exact same event. So we can keep it more organized by naming every function the same, but it's keeping it clear what side each function goes on, because each function will obviously have different behavior. And if we name them both ping, we won't be able to, because of course they're both just functions, which means it will get function ping has the same name as a previously declared function, which means that we cannot call them the same thing even if we wanted to. Additionally, I like to structure my RPCs in 3 sections, which are requests, RPCs, and RPC parity. Requests are functions from elsewhere. So for example, the game state manager might say request ping every 500 milliseconds or something. And the game state manager could call network core.s_ping.rpc, but it's better to keep network logic all in the same exact place. So the game state manager doesn't need to know how to RPC something. It just says, request a ping. Please just go do that for me, and then I will figure out what to do. And then the network core says, okay, I will figure out how to request a ping, which looks like this. The next section is RPC functions, which are the functions that are called from one side to the other. So on this one, the client has a pong function, which is called by the server. When the client calls ping on the server calls pong back on the client, which comes back and then ends up doing whatever we need to do here. Then we have the last region, which is RPC parity, which is necessary. As I mentioned, you have to have them synchronized. If we don't have this section and we just have the functions, it doesn't know where to look. It doesn't know what the function should look like when it's calling it, what the name is, what the arguments are, what the return type is, any of that, which means we have to make sure that this is the same. This is one of the most frustrating bugs that you can find when you're building a multiplayer game, because it's very hard to notice when you've accidentally changed one of the sides, because you don't have both scripts open at the same time, you're not constantly checking, but if you mess one of them up, it won't work. Interestingly, you can actually change the name of the arguments. So if we make this just arg, it will still work. It doesn't check the name, it just passes the values right in. Of course, it's probably cleaner and probably makes more sense to keep them named the exact same on both sides, but you don't have to, but I obviously would recommend it. There's another important piece of organizing RPC calls, which is to group them. So in this case, it's pretty simple because we have ping and pong, which is only 2. But if we have like player attack, player switch to item in hotbar, player use item, player jump, player crouch, all of these different like player actions, for example, we could collapse that into one RPC call. So we just have player action, and then we would have a identical enum or dictionary or something on both sides, and then we'd be able to say player action.call, and then we would say player actions.jump or player actions.swing weapon, and then the server would get that ID, which is just an integer instead of the entire different function call, and then use a switch statement over here to compare, and then dispatch the behavior to the game state manager of some kind. And I've been mentioning this game state manager a lot, and I'll explain why that is. So the way that RPC functions work is they have to have the same structure on both sides, which means that if I open up this globals window on both sides, you can see that we have network core is a auto load on the client, which is res network core.gd. So it has these functions for RPC. The server side does not have that, which means that when I run the project on the client, this is the client project, as you can see, we go to the remote tab, and we can see that we have root, which is the window itself, and then we have network core and world. The world is just our main scene, which is nothing in it right now. But we have the network core singleton up top at the very root level, right underneath the root window, which means that if we have an RPC function on the network core here, it will look for root network core on the server to call it. But on the server, when we run the project, we have the server project here, and if we check at the remote tab, we only have world because I have not set it as a global. So we will come in here, project settings, globals. We will find network core, and it will suggest network core, which is how you should name them, with Pascal case like that, capitals on the beginning of every word. And then we run it. We now have network core and world both up top, which looks the exact same as our client, which means that now when we call on the client side script sping.rpcid, it will go, okay, the current node path that we have is root network core. So then we'll call root network core.sping.rpcid with whatever arguments we have. Then on the server, we'll come to root network core.sping and give it the arguments here, which is very small. And then we get this. Then we go cpong rpcid, and it's calling network core.cpong.rpcid. So it goes back to here, root network core.cpong.rpcid on this side. And there's our callback. This is why I like to structure every single script with RPC functions on auto loads, because they get conveniently placed up here, and you'll probably have like at most 10 for different game types, game events. If you try and keep them on individual scripts, like the player, for example, you never know if you're going to have the exact same world structure on your client than on your server. You'll probably have different UI in here, like your HUD and your menu and all this stuff, which might clog up the client side a little bit more, and then you'll end up having a slightly leaner scene tree over here, which means that the path to the character might be different, which would mean that the RPC calls won't perfectly connect, but you don't want to have to deal with. So we put all of our RPC functions on auto loads at the very top level, and then we can just not worry about it, and we have all of these dispatchers, which we just call network core.requestPing. We don't need to worry about sping.rpcid because the network core handles that. You'll probably have more auto loads than just your networking ones, but that's fine because you can have the network ones, which will all start with network and then have whatever information they do here. So network core, network server, network game, network events, network explosions, whatever it is. And then other than that, you have other stuff like your global scene manager or whatever it is. The other thing that you should note is that the world, which is the scene that's currently loaded, is also up here. at the same level. So that is not important for the network stuff, but you could, in theory, if you have only one scene on your server, you could have your world scene or your debug menu or whatever it is with RPC functions on it. But I would not recommend that, and I'll show you why when we get to working on the actual server-side architecture. Alright, that is everything that I wanted to talk about for the first episode. I was basically just covering the metadata for the project, essentially. If you have anything that I forgot, drop it in the comments. The more documentation the open source community gets, the better. Subscribe for future tutorials. The rest of the series is coming out soon, and I will also eventually be posting devlogs for my own game that I was talking about in this video. Other than that, yeah, have a good day. Peace.